Good afternoon, one and all present here. Welcome to the BPI Secondary Virtual Science Exhibition 2021. Special welcome to our Administrative Head, Nupur Ma'am, Director Ma'am, Soma Bhattacharya, and Principal Ma'am, Shija Varghese. Science in today's life play a very important role, and life without science is unimaginable. We leave no stone unturned here at BPIS to bring out the best in our students, be it science, arts, or sports. Our students have never ceased to put their best foot forward and didn't let the global pandemic spoil their scientific temper. Now let us appreciate their hard work and dedication. Now, I would like to welcome the judges for this science exhibition. So the judges for this competition are Madam Shija Varghese, Dr. Hitesh Karia sir, and Rajeshri teacher. So now, let's welcome the students of Standard 6B, 6A. So our first participant is Rutu.
Good afternoon, respected teachers, ma'ams, and all my dear friends. My name is Ruttu Matre from class 6A, and today I'm going to talk about rainwater harvesting. So let's go and enjoy our water journey. Rainwater harvesting is the collection and storing of rainwater rather than allowing it to run off. This is my model of rainwater harvesting. So I'll explain it. So these are the clouds. From these clouds, the rainwater is collected on this rooftop. As you can see, these two conduits. Conduits are the pipelines of the rainwater harvesting system. From this conduit is attached to another conduit and it's passing downwards, where complex technique, which is underground dam, is built. Here is another conduit which is passing through the well. That the water is collected in this well. We can use this water for future use as well as this agriculture. Water is also getting collected in this tank. We can use this water for agriculture as well. Agriculture, cattle as well as general domestic use. So, save water, save life. If no rain, then only pain. Save water today, use it tomorrow. Thank you.
What a beautiful, innovative way to save water. Our next participant is Gargi.
Good afternoon, teachers and all my fellow friends. I'm Gargi Rao from grade 6A, and my topic is water cycle. In this model, we can see the representation of water cycle. As we all know that how water evaporates and rises into clouds and condenses into rain or snow. To display this model, I've drawn a sun on a glass jar, then poured some hot water to show water vapor. On the cap of jar, I have kept some cotton to give the effect of clouds. From this, we understand the sun is evaporating water and it is forming clouds, and then the clouds are condensing in form of rain or snow. This model is a miniature version of water cycle. Thank you.
Thank you, Gargi, for explaining water cycle in such a simple way. So now I request Maitri to take us through her experiment.
Good afternoon, everyone. I am Maitri Joshi from 6th day, and today I'm going to demonstrate an experiment about density of water. Friends, why do certain things float on water and certain things sink? It is because of the differences in their densities. But what is density? Density is about how tightly the molecules are packed. The objects with tightly packed molecules are more dense than those with loosely packed molecules. The objects more dense than water sink, and those less dense float. So let's do an experiment. I have taken 2 glasses of water of equal amount. In this glass there is plain water, and in this glass I have added some salt to it. Now I have these 2 gooseberries. Now let's see what happens.
In the first class, the gooseberry sank, as the density of the gooseberry was higher than that of the water. But in the second class, the gooseberry floated, as the density of salt water is higher than of gooseberry. Now let's see some interesting facts about density of water. The abnormal behavior of water between the temperature range 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. We know that density is equal to mass upon volume. So as the temperature decreases, the volume decreases. Thus the density increases. But below 4 degrees Celsius to 0 degrees Celsius, water expands instead of contracting. Hence, the density decreases instead of increasing. It is the abnormal behavior due to which aquatic life is able to survive under the frozen lake or pond. So why does this happen? As the water at the top gets cooled up faster and as its density is higher, it goes down and the water at the bottom comes up. But when the water at the top reaches 4 degrees Celsius, it doesn't go down and the density starts decreasing. Hence, the water below the frozen lake or pond starts at 4 degrees Celsius, which is enough for aquatic life to survive. Now let's see an demonstration. I've taken a glass of water and an ice cube. Now let's see what happens. We all would have expected for the ice cube to sink as it is a solid. But the ice cube floated. Why did this happen? Because the temperature of the ice was in the range of 0 degrees Celsius to 4 degrees Celsius, where the density of water is higher than that of the ice. That's why it floated. Thank you.
Great work, Maitri. Our next participant is Sakshi.
Good afternoon, everyone. Myself, Sakshi Rasil from Standard 6A, and today I'm going to show you an experiment. So let's start. For this experiment, we need cold water, hot water, and some color. So first, I'm adding some color in both the glasses. Now let's see what happens. Did you notice what happened? The color mixes through the hot water faster than it mixes with the cold water. This is because in hot water, the water molecules have more energy and are moving faster than the molecules of cold water. This makes it easier for the dye to get mixed throughout the hot water. Thank you.
Thank you for this marvelous experiment. Our next participant is Sanvi.
Good afternoon, one and all present here. Myself, Ms. Anita from Standard 6A. Today, my topic for science exhibition is water irrigation. Do you all know what irrigation is? Irrigation is the artificial process of applying a controlled amount of water to assist in production of crops. Irrigation helps to grow agricultural crops, maintain landscape, and nourishes soil in dry areas and during period of less rainfall. There are four basic types of irrigation, namely manual irrigation, channel irrigation, sprinkler irrigation, and drip irrigation. Today I have made a model of drip irrigation. Let me explain to you in detail. Drip irrigation is a type of micro irrigation system that has the capacity to save water and nutrients by allowing water to drip slowly to the roots of the plant, either from above the soil surface or buried below the surface. The goal is to place the water directly into the root zone and minimize evaporation. The drip irrigation is the efficient water and nutrient delivery system for growing crops.
Excuse me, Sanvi.
Yes,
Beta, are you showing anything? Because we are not able to see anything on the screen.
So my video is from other device.
Okay.
There on another screen.
So can I start again?
No problem. Continue.
Can I spotlight
So
her?
I will start again. Is it okay?
Yeah, you can start again, Sandy.
Good morning, one and all present here. Myself, Ms. Anvi from Standard 6. Today, my topic for science exhibition is water irrigation. Do you all know what irrigation is? Irrigation is the artificial process of applying controlled amount of water to assist in production of crops. Irrigation helps to grow agricultural crops, maintain landscapes, and nourishes soil in dry areas and during period of less rainfall. There are four basic types of irrigation, namely manual irrigation, canal irrigation, sprinkler irrigation, and drip irrigation. They have made a model of drip irrigation. Let me explain to you in detail. Drip irrigation is a micro irrigation system that has the capacity to save water and nutrients by allowing water to drip slowly to the roots of the plant, either from above the soil surface or buried below the surface. The goal is to place water directly into the root zone and minimize evaporation. Drip irrigation is the most efficient water and nutrient delivery system for growing crops. It delivers water and nutrients in the right amount at the right time so each plant gets exactly what it needs to grow properly. Here in the model, I have shown you two types of drip irrigation. They are outdoor drip irrigation and indoor drip irrigation. In outdoor drip irrigation, water flows under pressure and same gets dripped in the soil through the pipe leaves on the plant. In indoor drip irrigation, water flows with the capillary action under gravity. In this type, one end of the rope is kept in a big bottle or a pot and another end is kept in a plant pot so that with the help of the gravity, water can be supplied to the plant. We can use indoor drip irrigation when we are out of station for few days and there is no one to water the plant. I hope my presentation was informative and helpful to you. Thank you.
Great job done, Sanvi. So now let's welcome the students of Standard 6th B. Let's welcome our first participant from Standard 6th B, Rihanna.
Good morning, everyone. I am Rihanna Chavan, and today I will be demonstrating experiment on how to make rain in jar. For this experiment, we will need a jar, hot water, a plate, and ice cubes. First, we will take a jar and fill it with hot water. Then we will cover it with a plate and add some ice cubes over it. This way we can see how rain is formed. When the atmosphere of the earth is hot, it leaves water vapor and becomes clouds. The clouds create droplets that fall on the earth as rain. This process is called condensation or making rain in jar. In this process of rain, we can learn the three states of matter: gaseous state, water vapor, liquid state, water in rain form, solid state, ice or snow form. The boiling point of water is 100 degrees Celsius and melting point of ice is 0 degrees Celsius. The volume of ice is definite. The volume of liquid water in rain form is not in definite shape. It acquires the shape of the jar or container. The volume of gas is indefinite. The density of solid is less dense than liquid water. The density of water is 1 gram per cubic centimeter. It changes according to the temperature of substances dissolved in it. Density of gases have exceptionally low density. Like oxygen has 0.0827 gram per milliliter. Hydrogen has 0.052 gram per ml. Nitrogen has 0.072 gram per milliliter. Thank you. Thank you.
Very good, Rihanna. Our next participant is Diksha.
Good morning, teachers and my dear friends. Today, I am going to show you an experiment in which on solubilities of different substances. The substances we need for our experiment are potassium, permanganate, powdered chalk, some baking powder, and coffee. Before I start my experiment, I want to tell you something about the stretch of the intermolecular forces between the solutes and solvents determines the solubility of a given solute in a different solute. In order to form a solution, the solute must be surrounded or soluble by the solvent. So let us start our experiment. So I have put potassium permanganate in the glass and I have put water. As you can see that potassium permanganate is fully dissolved. So over here I have put powdered chalk in the jar. As you can see, chalk small particles are inside. It's not dissolvable, so it is insoluble. Now I put baking powder in the glass. As you can see that baking powder is not dissolvable because all the particles of baking powder are in the jar, as you can see. Now coffee. As you can see that coffee is fully dissolvable, no particles are there. So
What a brilliant experiment it was, Diksha. Our next participant is Nitika.
Good afternoon, everyone. My name is Nitika, and today I am going to perform an experiment based on one of the amazing properties of water, that is surface tension. Have you ever seen a bug skitter across the surface of a pond? Have you ever wondered why raindrops are the shape they are? This is because of the surface tension property of water. Surface tension is defined as the property of the surface of a liquid that allows it to resist an external force due to the cohesive nature of the water molecules. In this experiment, we will reduce the surface tension in water using a common household item. For this experiment, we will require a bowl filled with water, black pepper flakes, and liquid soap. First, I will sprinkle some pepper flakes on the water surface. Now, I will dip the finger into the liquid soap. Let's place it in the center of the water bowl. Did you notice this? The pepper flakes have moved away from the center of the bowl towards the edge. This is because water has high surface tension, which means the water molecules on the surface exhibit stronger attractive forces on the nearest molecules. The cohesive forces are so strong that when I first sprinkled pepper onto the water, it floated on the surface of the water. Then, when I dipped my finger in the soap and placed it in the water, the soap separated the water molecules from each other, thus lowering the surface tension in the center. But surface tension still exists in the other parts of the water. Therefore, water molecules close to the finger are pulled away by other molecules farther away, carrying the pepper along with them. And because the surface tension in the middle is reduced, some of the paper sinks to the bottom of the bowl as paper has a higher density than water. Surface tension performs many duties that are vitally important to the environment and people. Thank you.
Wow, that was too good. So now I request Arjun to take us through his experiment.
Hi, good afternoon everyone. My name is Arjun Arun and I am from Standard 6B. And today I am going to perform a refraction experiment. Now, before we get into the refraction experiment, let me explain to you what refraction is. Refraction is a phenomenon that is carried out when light travels from a rare substance to a more denser substance. When it travels from a rare substance to a more denser substance, it slightly bends towards normal. Now, let me show you what refraction is. All you need for this experiment is a glass container filled with water and any object to put inside the glass container. If you do not have any object, you can also use your fingers. Now, I am going to dip my finger inside this glass jar. Wow, look at this. It looks so much different. But it is not real. It is only an effect of refraction. Now, I am going to prove to you that refraction is consistent. I am going to put any two of these four objects inside this glass jar and show you that refraction is consistent across all substances. Now, I am going this pen inside the glass jar. Wow! Do you see how different it looks? But it's not real. It's only an effect of refraction. Now, I am going to take this toy bird and dip its tail inside the glass jar. Wow, it looks so much longer. But it is only an effect of refraction. So, to summarize what we have learned from this experiment, refraction is a phenomenon that is carried out when light travels from a rare substance to a more denser substance. When it travels from a rare substance to a more denser substance, it slightly bends towards normal. And refraction is also consistent across all substances. Thank you.
What a unique experiment. Our next participant is Arya.
Good morning, respected principal ma'am, teachers and all my dear friends. My name is Arya Kulkarni and today I will perform an experiment on balancing coins on card. For this experiment, materials required are an empty glass, a glass with water, a card and few coins. So let's begin. Step 1. First, put the card on the empty glass and place a coin on it. As you can see that the coin has fallen down because the card cannot bear the weight of the coin as the coin is heavier than the card. Step 2. Now put the card on the glass filled with water to its margin and place a coin on it. Let's add one more coin. As you can see that the coin has not fallen down. After this experiment, we observed that when we put the card on the empty glass and place a coin on it, the coin falls. And when we put the card on the glass filled with water till its margin and place a coin on it, the coin doesn't fall. So, how it happens? What is the conclusion? Wait, I will tell you. Water has the property of surface tension which holds the card firmly and balances its weight on the other side. For example, you guys know that spiders can walk on water. So, does it use any magic? No. The force of surface tension balances the spider's weight helping it to walk on water. Thank you.
Well done. Our next participant is Krish.
Hello everyone, I am Krish Yadevaya from 6th B. Our topic for this year's science exhibition is water. Water is used by humans every day for various purposes. Some of them are drinking, bathing, mopping the floor, etc. But some of the other important purposes of water are in industries, factories, and for agriculture. So now, let me tell you what I have built. I have built a simple water wheel. It is built out of cardboard and some ice cream sticks. The ice cream sticks act as the blade of the water wheel. The water falls from the earthen pot onto the sticks and causes it to spin like a wheel. In this process, energy is produced. This energy is converted into electrical energy. The electrical energy is converted into hydroelectricity with the help of generators and motors. So now, let me demonstrate my project. Can you see that? The spinning of the water wheel is caused because of the water falling from the earthen pot onto the sticks. In this process, the flowing water has energy. This energy is called kinetic energy. This energy is then converted into electrical energy with the help of the turbine. This energy is further divided through hydroelectricity, which can then be used in our home. So now, let me summarize what I have told. In dams, the water falls from the dams onto the turbines and causes it to spin. This water is then converted into hydroelectricity and can be used in our homes. Thank you.
Superb, Krish. So let us move forward and start with 7th A. Let's welcome our first participant from 7th A, Nupur.
Isn't it interesting and exciting to know that a plastic straw can make sound like a flute? Good afternoon, everyone. My name is Nupur Singala from Standard 7A, and my topic is instrument straw making sound. My first instrument is flute. The pitch, that is how high or low the sound is, varies depending on the opening of the hole. But why does the straw make a sound and the pitch is different? I will explain. The sound is produced by vibration of air blowing across the straw. Air blowing to shorter holes moves quickly. Vibration of air moves quickly and have a high frequency. High frequency produces high pitch. Thus, decrease in air column length results in quick movement of air, resulting in high frequency and high pitch. My another instrument is saxophone. It works on the same principle as a flute works. Now let us hear the sound of a pan flute. The concept behind the sound of a pan flute is that the pitch is inversely proportional to the length, so that the sound of the pitch is higher in the shorter straw due to its length, as the air column inside the straw is shorter. So you can also make different instruments, just like I have made a small pan flute, and its openings are closed. And did you hear the sound was different? Thank you.
Very good, Nupur. Our next participant is Yashvi.
Good afternoon, I'm Yashvi. Today I'm going to demonstrate an experiment on the topic idea of pitch vibrating balloons. For this experiment, we will require two balloons, a balloon pump, a smooth round object such as a marble or a bead, and an object with the corner such as hexagonal nut. Place the marble inside the balloon, inflate the balloon and then tie it. Now try spinning the balloon in a circular motion. Can you hear anything? The balloon with the smooth object will make little or no noise. You may hear a rattle a bit. Now let's do the same with the hexagonal nut. Try spinning the balloon in a circular motion. Do you hear anything? Yes, we can hear a loud whirring noise. What's going on? Sounds occur when a vibrating object causes the stuff around it, such as air, to vibrate. When the vibrations reaches our eardrums, our auditory nerve carries the information to our brain. So now we can introduce the concept of pitch. When we have a fast moving hexagonal nut, we will be able to feel and hear a very high pitched sound. When the hexagonal nut moves slowly, the sound would be very much lower in pitch. Thus, from this experiment, we can conclude that the pitch of a sound depends upon the frequency of the vibrations. A high frequency vibration causes a high pitched sound, whereas a low frequency vibration causes a low pitched sound. As the nut slows, the vibrations drops in frequency and the sound drops in pitch. Thank you.
Thank you for increasing our knowledge. Our next participant is Siddhant.
A very good morning to respected madam, teachers and all my dear friends. My name is Siddhant Surajmaikar and I welcome you in my science exhibition, and my topic is sound travels through solid and liquid. This is Jal Tarang. It is the best example for sound travels through solid and liquid. You can hear the sound. This sound is produced because of the vibration created in the liquid molecules. The vibration created in the liquid molecules create the sound. Now let's go with the solid experiment. For this, we need a cardboard box. Now bang the cardboard box with a finger. You can hear the sound. This sound is produced because of the vibration in the molecule. As we know, solid molecules are tightly packed to each other. So the sound travels faster in solid. Therefore, we can conclude that sound travels faster in solids compared to liquid and gases. Thank you.
Thank you, Siddhant, for explaining it in such a nice way. So, now I request Srishti to take us through her experiment.
Good afternoon. I am Srishti Suvarna. Today I am demonstrating an experiment to prove that sound requires a medium for its propagation. Sound is a form of energy. It can travel through any medium, like solid, liquid, or gas, in the form of waves. Sound cannot travel through vacuum. To demonstrate this fact, I've taken a glass jar with an airtight lid. On the lid, I've connected a vacuum pump with a tube. Initially, the vacuum pump is switched off. That means there is air present inside the jar. Now, when I switch on the buzzer and place it inside the jar and close the lid, the sound is still audible to us. Now, when I turn on the vacuum pump, it starts sucking the air inside the jar. After some time, you will notice that the level of sound inside the jar has reduced due to a decrease in the quantity of air inside the jar. If the vacuum pump is used for a sufficiently long time, the level of air inside the jar will be so low that the level of sound not be audible to us, since there will be no medium in it. Thus, this experiment proves that sound requires a medium for its propagation. Thank you.
Excellent, Shrishti. Our next participant is Janisha.
A very good afternoon to respected madam and teachers present here. I, Janisha Vipada from Standard 7A, would like to present an experiment on the topic sound. For the experiment, all we need is a glass and water and a steel spoon. Pour the water in the glass. Take the steel spoon and hit it. Now wet your fingers and rub your moistened finger along the rim of the glass. Could you hear anything? Was this a magic? Oh, of course not. It happened due to your fingers that stick to the glass as it encounters friction when it moves over the glass surface. The sides of the glass transmits the vibration to the surrounding air, creating the sound waves. Now, friends, when you add more water to the glass, the pitch becomes lower. This is because the high volume of water in the glass makes it more difficult for the glass particles to vibrate. So the vibrations of the glass are slower and they have a lower frequency. When the water was less, the pitch was higher. Thank you.
That was awesome. So now let's welcome the students of Standard 7th B. Our first participant is Aditi.
Good morning, everyone. My name is Aditi from grade 7th B. I'll be presenting an experiment on sound vibrations. My experiment name is Sound Creates Vibrations. Apparatus I will be using are a glass, balloon, black mustard seeds, phone, and speaker. Now let's begin. You can see I have taken this rubber balloon and stretched it completely, which I'll be placing black mustard seeds. Once I start, these particles are motionless now. They are not moving because they are not receiving energy. No work is being done on them. Once I start playing a loud music, let's see what's the effect. We could observe that the particles on the membrane of the balloon vibrates and the particles kept on the membrane starts dancing. Why this happens? This experiment proves that sound is a form of energy. Sound produces vibration. Larger the sound beat, larger is the vibration. We can see in this form of particles dancing to a larger extent. Since they were receiving energy produced by the music, the particles were in motion. Thank you.
Thank you, Aditi. We all could feel the vibrations. Our next participant is Jignasa.
Good afternoon. My name is Jignasa Mhatre from class 7th B. Today, I am showing you how to visualize Sound is a wave. Every sound is produced by vibration. Vibration is an back and forth movement of an object. You can hear only when sound energy reaches your ear. As you speak, vibration is produced by your vocal cords in the throat. But how does sound energy travel? Sound energy travels in the form of waves. Let us see demonstration. How does sound waves work? These sound waves travel in different speed in different mediums. The medium could be solid, liquid, or gas. I have made this model. I have used this plastic string to show longitudinal wave. This is Rob and this is Bob. Now we are going to understand the longitudinal wave by the string.
Wow, Rob, this is a longitudinal wave.
You notice some of the plastic string coil crowd to close together and then slowly move from Rob to Bob and return. This is longitudinal wave. In a longitudinal wave, particle vibrations are parallel to the direction of wave from Rob to Bob or anti-parallel to Bob to Rob. So we can hear echo sound. Thank you.
Great work, Jignasa. So now I request Madhu to take us through his experiment.
Welcome and good morning, one and all present here. Today I present a presentation on topic sound travels through solids and liquids. So for the experiment, we need a box and a source of sound. Now I will play the song and put it into the box. Thus we can hear the sound through the solid. This proves that sound travels through the solid. Now let us do the second experiment. So for the second experiment, we have a bell and a bowl full of water. Now we will try to ring the bell inside the water and try to hear it. Thus, we can hear the voice of the bell from inside the water also. Thus, this experiment proves that the sound travels through both solid and liquid. Thank you.
What an innovative experiment. Our next participant is Trishna.
Hi, good morning everyone. Good afternoon. I, Krishna Gowde from Standard B. Can I hear you? Yes, of course. And this is possible because of one part present in your ear. That is your drum model. Your ear drum. So this is our ear drum model. So my today's topic, you would understand that my today's topic is ear drum model. So first I would like to explain you this part. So this is the arrow line. This is the main part which is present in your ear. That is eardrum. This is the auditory canal. This is the coil. Now I would explain you how we can hear. Your eardrum is really important part of your ear. Sound waves travel through the ear canal to reach the eardrum. Your eardrum is a thin flap skin that is tight like a drum and vibrates when sound hits it. This vibration is the tiny bones of the middle ear which sends vibration to the inner ear. From the inner ear, this message is sent to the brain, which says, "Hey, I hear something." So feel those good vibes. Thank you.
What a beautiful model. Our next participant is Devika.
Good afternoon, one and all present here. I am Devika Iyer from grade 7B. Our topic for this year's science exhibition is sound. Today, I will be presenting a few musical instruments. The first musical instrument I present are the castanets. The castanets are usually made with shells. Here, I have used spoons in place of shells. Can you hear that? In the castanets, the vibration between the spoons produces sound. This is how the castanets look. The next musical instrument I present is the harp. Can you hear that? In the harp, when you pluck a string, energy is sent through the string. This makes the string vibrate, producing sound. The next musical instrument I present is the drum. Can you hear that? We all think that if we hit a drum and sound is produced, but that's not all. A drum is a percussion instrument. That means it produces sound when its surface is scraped or hit by an object. In the drum, a tight membrane is stretched over its body. When you hit the membrane moves up and down many times per second, pushing the air below. This creates sound waves and music. The drum is also an excellent example to prove that sound travels in waves. Mridangam and tabla also work in the same mechanism. The next instrument I present is the shaker. I have used a container and some pillows for preparing this. In the shaker, when the beads impact on the inside of the chamber, sound is produced. Thank you. Hope you enjoyed this musical journey.
It was out of the box thinking. Now we'll start with the students of 8th. Our first participant from Standard 8 is Rudra.
Good afternoon, dear teachers and friends. I am Rudra Manjrekar from Standard 8, and for today's science exhibition, I'm going to present a model of a periscope. This is the model of a periscope which I have created. A reflecting periscope demonstrates the law of reflection of light, which states that the angle of incidence is always equal to the angle of reflection. A periscope consists of a cylindrical cardboard tube bent twice at right angles. Two plane mirrors are fixed at the bends of the tube at an angle of 45 degrees. The inner side of the tube is blackened to avoid any reflection of light. The parallel rays entering the cylindrical tube from the upper end of an object strike the plane mirror at an angle of 45 degrees and hence are reflected through an angle of 45 degrees. This reflected ray strikes the second plane mirror at an angle of 45 degrees and is further reflected through an angle of 45 degrees. Finally, the reflected ray reaches the eye and the image of the object can be viewed from the other end. Periscopes are used in submarines to see the objects on the surface of the water and by soldiers present in trench warfare to observe the movement of the enemy. I'm going to be showing the cap of a highlighter through the periscope. Is it visible? Yes. Thank you.
Marvelous model. Our next participant is Yash.
Good afternoon, everyone. I am Yash Majid, and today I will be showing you my project on slide projector. Slide projector is an optomechanical device for showing photographic slides. Light passes through the transparent slides and through the magnifying glass and is projected onto the screen. The slide should be placed in the holder in an inverted manner. It uses the principle of convex lens imaging to project image onto the screen. Movies were projected in this way until the late 20th century. Now let's show a live example for more understanding. As you see, the inverted image into the slide is coming right on the screen. Now let's place another image. see how it looks. Now let's place the third image. As you see, the third image is an inverted flower. Now let's place the final image. Thank you.
Outstanding model. So now I request Madhuri to take us through her model.
Good afternoon, everyone. I am Madhuri Asulkar from class 8. Today I will be performing an activity on refraction of light. I have an image. This image shows an arrow pointing towards the left. When I place a glass of water in front of it, the arrow points towards the right. What is this? This is called refraction of light. The change in direction of light when traveling from one medium to another medium is known as refraction of light. Here, the two mediums are air and water. Why does refraction take place? The change in medium changes the speed of light. This is the reason why refraction of light takes place. How did refraction occur in this case? The rays of light emitted from the image reach the glass of water. These rays are known as incident rays. The point at which the incident rays strike the surface of the glass is known as point of incidence. The rays of light which travel from the point of incidence through the water and reach our eyes are known as refracted rays. The point of incidence is the point where the change of medium takes place. Thus, light bends, causing the refraction of light. This is how the refraction of light has taken place in this activity. Thank you.
Very nice. Our next participant is Palash.
Hello everyone, my name is Palash Gala and today I am going to do an experiment to prove that light travels in a straight path and it can be reflected. So the materials we need are a mirror, a comb, some pieces of clay, a torch and a dark room. So now basically our procedure is that we have to take the mirror and place two pieces of clay on the side of it. And then we have to do the same with the comb, but keep it in front of the mirror with a gap of 20 centimeters or more. So now, then basically we have to just turn off the lights and use our torch. So now let's move on towards the observation. First, just let me turn off the lights and then we are going to use our torch. I hope you guys can see the light rays. The light rays which are going towards the mirror are called the incident rays. And now I will tilt the mirror just a little bit. And now you guys can see the square spaces formed between the light rays. These are called the reflected rays. So the incident rays and the reflected rays together form some square spaces between the light rays. So hence we can conclude that light rays travel in a straight line and they can be reflected. I hope my experiment was informative to you. Thank you.
Very good, Palash. Our next participant is Yatharth.
Hello everyone, I am Yadha Gupta from class 8. Today I am going to show you a science experiment on dispersion of light using this glass prism. I have three things here: this prism, this white paper as the screen, this torch as the source of light. You will observe that when I pass white light through this prism, a band of colors is formed here. You can see this band of colors formed here. How is this band of colors formed? When the incident ray of light passes through this prism, as you know that the light is composed of all the 7 colors, each color slightly bends. First to bend is the red, then orange, and so on till violet. Red has the maximum wavelength and violet has the least wavelength. This experiment was first done by Sir Isaac Newton. Dispersion of light is the phenomena in which, after passing white light through a glass prism, is a phenomenon of splitting of white light into its constituent 7 colors on passing through a glass prism. This is how a rainbow occurs on a rainy day. On a rainy day, after the rain has occurred, when the sun shines, there are still some water droplets present in the air. When the sunlight passes through these water droplets, each water droplet acts as a prism and disperses the light into its constituent 7 colors. And this is how we see the rainbow. This phenomena of dispersion of light can also be seen in series, soap bubbles, and in water fountains. Thank you.
Awesome. Our next participant is Arnav.
Good afternoon, one and all present here. My name is Arnav Shettigar, and today my topic for science exhibition is a periscope. A periscope is a very good example of laws of reflection of light. In a periscope, when an object is kept here, the light rays from the object fall on a mirror that is kept at a 45-degree angle at this corner. Then it falls at a mirror which is also kept at a 45-degree angle at this corner till it reaches the human eye here. Now let's see how this ball looks through a periscope. Can you see the ball? Yes. Periscopes are generally used in submarines to see what is happening on the surface of water. They are also used in tanks and armored vehicles to see what are the enemy's movements on the land. Periscope was invented by Julius Carpentier, a French engineer and inventor. Now, what exactly is a periscope? A periscope is defined as an instrument used for observing over, around, or through an obstacle or object which is prevented by a direct line of sight. Pros and cons of periscope in real use. Advantages: easy to repair in submarines, tanks, and armored vehicles. Helps to locate enemies faster in submarines, tanks, and armored vehicles. Can even function after minor damages in submarines, tanks, and armored vehicles. Contributes in protecting the land. Disadvantages: ruins the tourism industry. Can be easily displaced by waves in submarines. Does not absorb all the surrounding light due to gaps between the backwater. It is really expensive. Thank you.
Great job done, Arnav. It gives me immense pleasure to deliver the vote of thanks for this event to dignitaries assembled here. I would like to thank our judges who honored this event with their inspirational thoughts. I would like to thank our beloved principal ma'am, teachers, students, and participants for making this event successful. Once again, I thank one and all present here and would request our principal ma'am to speak few words on this event.
Yeah, good afternoon, children. I hope I'm audible.
Yes, ma'am.
Yes, science is something which you do every day. Science is which you encounter every day, and your curious mind, your curiosity needs to be enlightened in whatever you do, whatever you come across in your day-to-day life. You should start asking questions why it is happening. There is science in everything that you do. Like you saw various experiments that the children have done. You saw science related to sound, you saw science related to light, you saw the science which is present behind plants. So if you open your eyes and see and you look around, you will see science is there every day. And there is a reason behind everything that happens. And that is what we want you children to do. Whatever you encounter in your day-to-day life, whatever you come across in your day-to-day life, start finding out what is happening. What is the scientific reason behind it? There is nothing that happens without a reason. There is a scientific principle behind everything that happens. Okay, so that is what you need to do. You are taught theoretically in your class. Your teachers use various aids. They tell you various examples. They even show you experiments in the class. But then you need to take it further. You need to start thinking why all this is happening. And that is what leads to inventions and discoveries. When you encounter certain difficulties in life, you try to find out solutions for it. Yes, and that leads to inventions and discoveries, and that is what you children need to do. Okay, that is why basically we have these science exhibitions or science projects that you do. You should start questioning things and start finding out reasons for why a certain phenomenon happens or why certain things take place. Like in simple, in your day-to-day life around you, if you see during the rainy season, if you keep salt somewhere, it starts collecting water. Why it happens? What is happening to salt? Like you saw experiments children doing, they took plain water, they took salted water, and the density of salted water was more than the plain water. And therefore, if you put things into the water, it will sink in plain water, it does not sink in salted water. So what we basically aim from having science exhibitions, and I want more children to come up with more innovative ideas and more innovative experiments. But well done, children. Everyone who participated, they have done a very good job. We'll be compiling the result and coming out with the results soon. But well done by all the students. Thank you, children.
Thank you, ma'am.